Well, here we are in Chapter 6. Chapter 6, we're going to be solving a lot of trig equations. Section 6.1 is going to be basic trig equations. 6.2, medium, and 6.3, a little more advanced, but all solving trig equations. And we're going to be using these graphs over and over and over again to help us solve easy, medium, and even harder trig equations. So please make sure that you know the basic graph of sine, and you need these 3 points. For cosine, and you should know where 0, pi, and 2 pi are on the graph. And then for tangent with its asymptotes at negative pi over 2 and pi over 2. Now let's get to solving some trig equations. So for example number 1, so with this we're going to be working with radians, so find all solutions in the interval from 0 to 2 pi. The first one, cosine of x is equal to a half. So you could use the calculator and take cosine inverse of both sides. You'd get x equals cosine inverse of a half. And that's definitely something you need to do. In fact, I think I'll just go ahead and do that right now. The only problem with this is it only gives us one solution. And this problem has 2 solutions. But you do get one solution by using cosine inverse. So then ask the calculator, first of all, make sure that it's in radians. And then ask the calculator, what is cosine inverse of a half? So it gives me this decimal, 1.047. But I'm pretty sure that that is something like pi over 2 or pi over 3, something like that. I now want to see, what is it? Pi over 2, pi over 3? So what I'll do is divide by pi. And when you do this, just hit the divided so that it says the answer. So it's taking this last answer, dividing by pi, and then before you hit enter, go to math, change this to a fraction, and it says that it's 1/3. So that means that it's 1/3 of pi, or pi over 3. So that is definitely one of the solutions. And like I said, we now need to use the graph because there's multiple solutions. So if you just draw the graph of cosine, it doesn't have to be fancy. Right here's 2 pi, in the middle is pi. And then this equation is saying, take a look at the graph of cosine. When is the y value equal to a half? So on the y-axis, 1/2 would be right here. And if you draw a line straight across to see when cosine equals a half, there's actually 2 solutions. So one solution is the pi over 3 that the calculator just gave us. The other solution is over here on the right. So now we need to find out where this value is. Now what we do is use the fact that the graph is symmetric. So whatever shape is over here, the same shape is over here. Or whatever length this is, so going from where the graph is at its tallest to the answer that we just found, this is a length of pi over 3. Well, by symmetry, that means this is also a length of pi over 3. So this answer is to the left of 2 pi by pi over 3. So that means it's going to be 2 pi minus pi over 3. So that's going to be the second solution. Then if you get a common denominator, this is going to be 6 pi over 3 minus pi over 3. And then that equals 5 pi over 3. So now my 2 solutions are x equals pi over 3, x equals 5 pi over 3. And that is number 1. And of course I could even check it, take 5 pi over 3, plug it in for x right here, and the answer should be exactly 1/2. So if I take cosine of 5 pi over 3, then the answer should be exactly 1/2, 0.5, or 1/2. So that's correct. Okay, now on to example number 2. Again, we're finding all solutions in the interval from 0 to 2 pi. And then for this one, just make it sine equals 1/2. So, like last time, we could first take sine inverse of both sides. So in other words, find sine inverse of 1/2. Sine inverse of 1/2. And then this is probably pi over something. So to find out, hit divided by pi and convert that to a fraction. So it turns out it is 1/6 of pi, or pi over 6 is one answer. Then to find the next answer, take a look at the graph of sine. So sine starts at the origin, goes up, then goes down, and then finishes one cycle by the time we get to 2 pi. And again, this part is saying, take a look at the graph of sine, and when is the y value equal to 1/2? So on the y-axis, right here would be 1/2, and if you make a line go straight across, there's actually 2 solutions. So one is right here, and that is the pi over 6 that we got from the calculator. The second one is over here, which is actually to the left of pi. And then use the same idea of symmetry. If this is a length of pi over 6, then this is a length of pi over 6. So this second answer is to the left of pi. That means it's going to be pi minus pi over 6. And then this will be 6 pi over 6 minus pi over 6. So that is 5 pi over 6. And then we're done with this one. So x equals pi over 6 is one answer. X equals 5 pi over 6 is another answer. Now let's do the same thing with tangent. So what if tangent was equal to 1/2? Example number 3, tangent is equal to 1/2. And like with the other ones, you can take tangent inverse as a first step and get one answer. Second, tangent inverse of 1/2. And then, what is that a fraction of pi? So they aren't always. Sometimes you just have to deal with the decimal, but sometimes they're pi over 6 or pi over 3, etc. So go divided by pi, change that to a fraction. And the calculator could not come up with a fraction. So that means that this answer, 0.464, that is not something that is just pi over 2 or pi over 3, something like that. So that means that we just use the decimal answer, 0.464. That actually ends up happening quite a bit, that we use the decimal answer. So x equals a 0.464. So when you do this idea right here, if you get a fraction, that's cool. Go ahead and use it. But if you get a decimal, this decimal right here is no use. So forget about that one. The answer is 0.464. Now, of course, that's not the only answer. If you look at the graph of tangent, it has these asymptotes at negative pi over 2 and positive pi over 2. And then the graph goes like this. Well, in the directions, it said to go all the way out to 2 pi. So with the other graphs, once I did one cycle of it, that was already 2 pi. But with this one, I'll have to draw another branch of the tangent. And this period is a period of pi, or length of pi. From negative pi over 2 to positive pi over 2, that's a length of pi, which means that right here, it's hitting the x-axis at pi. And there would be another asymptote over here at 3 pi over 2. And then if you keep going, the next time it hits the x-axis is at 2 pi. And usually I would keep graphing the rest of it, except the interval said stop at 2 pi. So this is the graph that we need to use. And again, this is saying look at the tangent graph. When is the y value equal to a half? So draw a line straight across, and it looks like there's two answers. So this first answer is the decimal that we just got. So right here, x will be 0.464. And then what about this one? Well, this one is to the right of pi. And again, use the idea of symmetry that this length and this length are the same. So that means this one is to the right of pi, so it's going to be pi plus a 0.464. So pi plus 0.464 is 3.606. And then those are the two solutions. So we get the decimal answer, x equals a 0.464. Also, x equals a 3.606. Okay, then let's do something that is a little more challenging. Example number 4. How about the square root of 3 plus 5 sine of t equals 3 sine of t? So the first thing we need to do is make it look something like this, where it just says sine equals a number. Because once you have it simplified to sine equals a number, then you could do sine inverse, and then that gives you your first solution. So we need to collect all the sines together. I'll collect them on the left side. So subtract 3 sine of t from both sides. So that leaves 2 sine of t. And now it's equal to 0. And next, subtract this from both sides. So it's going to be 2 sine of t equals a negative square root of 3. And then divide both sides by 2. So sine of t is equal to negative the square root of 3 over 2. Excellent. Now that we have sine equals a number, you can use sine inverse. And then sine inverse of negative the square root of 3 gets divided by a 2. And then to see if that is pi over something, divide it by pi and change that to a fraction. So it turns out that it's negative pi over 3. But we're supposed to find all the answers from 0 to 2 pi. So basically, you are looking at the graph of sine. So we're basically graphing this part right here. So look at the graph of sine, which looks like this. Right here's 2 pi. Right here's pi. And then this is saying, when does the y value equal a negative radical 3 over 2? So a negative radical 3 over 2 is approximately right here. And draw a line straight across, and it gives us 2 answers. Now the negative pi over 3 that the calculator found, what it did is it's programmed to find the answer that's closest to the origin. So what it did is it went this way, because the graph of sine goes to the left and to the right forever. And it went right here, and it found that this is negative pi over 3. So that means that this gap between the answer that we're looking for and where it hits the x-axis, that's a length of pi over 3. Negative just means it went to the left. So when we go to look for this answer, that means that this gap right here, this length, that's a length of pi over 3, which means this answer is to the right of pi by pi over 3. And this answer, so right here is the 2 pi, and this answer is to the left of 2 pi, so that means it's going to be 2 pi minus pi over 3. So let's see, so this one is going to be 3 pi over 3 plus pi over 3. So that is 4 pi over 3. And this one will be 6 pi over 3 minus pi over 3. So that's 5 pi over 3. So then, to make it look all nice, x equals 4 pi over 3. And the other one, x equals 5 pi over 3. Now I want to just randomly pick one of these answers and check and make sure that it's right. So what I'm going to do is take this one and plug it into the original equation. And you can do it on the home screen. You can also do it by graphing. So if I graph this, this is going to be y1 and this is going to be y2. Square root of 3 plus 5 sine, the calculator wants to use x instead of t, that's fine. And then 3 sine of x. Change the window to go from 0 to 2 pi. And then this could get as big as 5 plus something else. So on the y values, maybe go from negative 8 to positive 8. And then, so it's right now it's graphing this. And when it's done, it's going to graph this one is in red. And there's 2 places where they intersect. So right here, that should be the 4 pi over 3. And right there should be the 5 pi over 3. So then I'll just go trace and plug in a 5 pi divided by 3, and that should be that point right there where they intersect. So let me try to get it. It should be right there. Oh, so close. From my angle it was perfect, but from the screen. Anyway, so that is the intersection point. So got that one right. Okay, just one more. Example number 5. So make it a little more challenging. How about 2 cosine squared plus cosine of x minus 1 equals 0. So like I said, we need to get this to say cosine equals a number. So we need to simplify this. With this one, it could be factored. So in order to get a 2 cosine squared, that came from having a 2 cosine of x times a cosine of x. When you multiply those, we get the 2 cosine squared. Now to get the number 1, that would come from a 1 times a 1. And now one of these needs to be positive and one of them needs to be negative. So this is going to get multiplied with this. So I think that this is positive and this is negative. And then if you check to make sure that the middle term is right, these two, when you multiply them, is going to be a positive 2 cosine of x. And then these two will be minus cosine of x. And that leaves positive cosine, which is correct. Then after you've factored them, you break this into 2 simpler problems. One is, where does 2 cosine of x minus 1 equals 0? And the other one, cosine of x plus 1, where does that equal 0? And these are now separated into 2 separate problems. So with this one, add 1 to both sides and then divide by 2. So that would leave cosine of x is equal to a half. Deja vu, I think we did that one. That was example number 1. So since we did that one, I'll just go through it real fast. Cosine graph looks like this. The 1/2 would be right here. When you do cosine inverse of a half, cosine inverse of 1/2, divide that by pi, ask for the fraction, that's pi over 3. So this solution is at pi over 3. And this solution, well, right here is 2 pi. And this solution is to the left of that. So this one is going to be at 2 pi minus pi over 3. And then that's going to equal 5 pi over 3. So for this part of it, we get the 2 answers. X equals pi over 3. X equals 5 pi over 3. That's 2 of the solutions. And now onto this one. So subtract 1 from both sides. Cosine of x is equal to a -1. And then you could do cosine inverse. So cosine inverse of -1. Oh, I recognize that. That's pi. X equals pi. And if you look at the graph of cosine on the interval from 0 to 2 pi, there's actually only one place where it's equal to -1. It goes straight across, and there's only one solution for this one, and that is pi. All right, so that's section 6.1. Talk to you soon in section 6.2.